Welcome back. This is the second lesson recording for IM2, April 12th, 2021. So where we've left off, you're taking notes on this area of a regular polygon. You're going to find that by finding the area of one triangle and then multiplying that by the number of triangles. And you're going to find the area of one triangle is going to be half times apothem, because apothem is going to be the height of the triangle and the side length is going to be the base of the triangle. And then you need to multiply that area by the number of triangle, which is same as the number of sides. So that becomes half times A times S for side length times N. N is the number of sides. And if I rewrite this and put the side length and number of sides together, what do we get? Side length, each of the side length is S, multiplied by the number of sides. That's going to give me the perimeter. So we can rewrite this equation as half times A times P, P being the perimeter, A being the length of apothem. So you have two different formulas. You can have half times A times side length times number of sides, or half times A times P, which is perimeter. Now we're going to go on to level 2 of area of regular polygon. Before we do that, we're going to do a slight diversion. Do we have enough information to find the missing sides? So with A, if I am given this right angle triangle, and we know that it's right angle because of this little square, with the leg length of 6 and 8, can we figure out what the hypotenuse is? How do we do that? Hopefully you're telling me you can find the third length, the hypotenuse, by using Pythagorean Theorem, and that's going to be leg squared times leg squared plus leg squared is going to be the hypotenuse squared. So it's going to be 6 squared plus 8 squared is going to be, if I call this x, x squared. So that's 36 plus 64 is 100. So x squared is 100. So x is going to be square root of 100, which is 10. So we have enough information. What about this triangle? What if you're given the hypotenuse length, but instead of giving another leg length, you're given an angle measure? Do we have enough information to find the other length? Or we have two things plus the right angle, right? So we have one angle, another angle, and the hypotenuse. So in this case, what do we use? We're going to use the trig functions. Okay, so trig shortcuts, what do we have? We are given the hypotenuse. This is the hypotenuse because it's opposite to the right angle. So this is going to be the hypotenuse. And we're going to be looking for, let's start by this side. Okay, so this side is going to be what? This is adjacent side to the angle that we're dealing with given. Okay, so it's right next to us, so it's adjacent. And this is going to be opposite from the angle that we're talking about. So this is going to be my opposite side. So to figure out what theta is, we're going to use what is the trig function that deals with adjacent and hypotenuse. That's cosine, right? So cosine of 36 degrees is going to be adjacent over hypotenuse. So that's going to be, we call that question mark divided by hypotenuse, that's 8. So the question mark is going to be 8 times cosine of 36. What about the question mark? That's going to figure that out. We're going to use sine of 36 is going to be opposite, which is question mark length divided by hypotenuse, which is 8. So again, to figure out the question mark, we're going to multiply 8 by sine of 36, which you can find using the calculator. You do not have to use the trig table anymore. Use the calculator, that you're going to have access to that all the time. Okay, what about this problem? Okay, this time we're given the hypotenuse and the right angle, but no other information. Do we have enough information to find the missing side? No, we don't. We need at least another side length, or we need an angle. So not enough information. What about D? If you're given one of the leg length and we're trying to figure out the hypotenuse length and another leg, what trig function would we use? Well, to figure out, well, this length is hypotenuse because it's opposite from the right angle, right? And this is right next to the angle that we're given, angle measure that we're given. So that's going to be adjacent. So which is the trig function that deals with, and this is the opposite side. So we know the opposite. So to figure out what question is, we're going to look for trig function that deals with opposite and adjacent, and that's tangent. Tangent of 36 is going to be equal to opposite, so katoa opposite, which is 6, divided by adjacent, which is question mark. Okay, so how do we figure this out? We multiply both sides by question mark, and you get question mark is going to be 6 divided by tangent of 36. Similarly, to find the hypotenuse, you are going to use which one? Okay, so we have opposite and hypotenuse, so that's going to be sine of 36 is going to be opposite, which is 6 divided by question mark. Like, all right, then what about the last one? Okay, do we have enough information? Yes, we have angle and the leg, so we're going to use trig function again to find the length. So with that, remember to find the sides of a right triangle. When you're trying to find the length area of a triangle, you might need to find the missing side length of a right triangle. And to do that, you can certainly use your trig functions as well as the Pythagorean theorem, leg 1 squared plus leg 2 squared is hypotenuse 2 squared. Okay, so and you are going to work on Desmos card number 4 to 7. Correction, you're working on card number 7 to 10. So here we go. So unknown side length 1. Which tool would you use to find the length of x? Okay, so we're given this triangle. What do we know so far? We know what is this side? This is the side length x. They're both x and 13. They're both legs of this right triangle. How do we know? Because they are right next to the right angle symbol. Okay, so they're both legs, which is this x is relative to the angle that we're given. It is adjacent. So we can say we have adjacent side, and this is opposite to the angle that we're given, so that's the opposite. So which is the trig function that deals with adjacent and opposite? That's tangent, right? So tangent of 25 is going to be SOHCAHTOA, so that's going to be opposite over adjacent. What's opposite? That's 13 over x. How do I solve this? I need to multiply both sides by x to bring the variable x to the top, and then that leaves us with x times tangent of 25 degrees is going to be equal to 13. So divide both sides by tangent of 25 degrees. So x is going to be equal to 13 divided by tangent of 25 degrees. So that's the trig function we are going to be using. We're going to use tangent of 25 and solve for x. X is going to be 13 divided by tangent of 25. which is going to be equal to, which when I use the calculator, I get 27.9. So submit that. What about this problem? Okay, what trig function am I going to be using? Well, we have a right triangle. We're given two of the legs and the hypotenuse. Well, we're not going to use the trig function. We're going to use Pythagorean theorem, won't we? And then how do I figure that out? Well, I know that it's going to be leg squared plus leg squared is going to be 16 squared. So x squared plus 11 squared is going to be equal to 16 squared. So x squared is going to be 16 squared minus 11 squared. So x squared plus 11 squared is equal to 16 squared. So x is equal to 16 squared minus 11 squared, which is 256 minus 121, which becomes 135. So I don't want x squared, I want x. So I take a square root of both sides. So x is going to be square root of 135. When I use the calculator, it gives me approximately 11.6. So I know that x is going to be approximately 11.6. And make sure that when you put the value in, it makes sense. I mean, if you're getting really big number or really small number, and when you know the values and the triangle, you know that you've done something wrong. Okay. Card number 9. Okay, so you have which tool would you use? Which tool would you use? We are given an angle and we're given the hypotenuse, and the opposite side is the side in question. So we are looking for trig function that deals with opposite and hypotenuse, and that's going to be sine of 17 degrees. Then from here, I'm going to do my calculation. So sine of 17 degrees is going to be equal to SOHCAHTOA. TOA. So is opposite over hypotenuse, and opposite we said was x divided by 19. So x is going to be multiplying 19 to both sides, 19 times sine of 17 degrees. Which when I use the calculator, I get 5.6. And again, check your answer to see if your answer is reasonable. And it certainly does look reasonable. So I know that I probably got it right. Okay, which tool should I use? Okay, so I have a right angle, and we have a leg here, that's hypotenuse. And which is this? This is next to or adjacent to the angle that we're given. So this is going to be adjacent. So which is the trig function that deals with adjacent and hypotenuse? That's going to be cosine. And x is, so to do that, I'm going to do cosine of x. Oh no, 52 degrees is going to be ka of adjacent over hypotenuse. Adjacent is x and hypotenuse is 15. Multiplying both sides by 15, x is going to be 15 multiplied by cosine of 52 degrees. And when I use the calculator, I get 9.2. And again, I check my answer to see does it look reasonable. If the hypotenuse is 15, it's about 52 degrees. Does it seem right that this length is going to be 9.2? And that sounds correct. And we'll go back to our slides and continue on our next lesson recording.